Hello, this video is to give you what you need to know for the proofs unit of your high school geometry class. So the purpose of doing proofs generally is that you are doing them to learn and to practice logical thinking. That's why you're doing them. And when you're doing proofs, as like in real life, you can't just say something is true. You actually need to convince people it's true. You have to prove it's true. And so learning these proofs will help you do that. And this is very much like what lawyers do in a court when they're trying to prove someone is innocent or guilty. And to do this, lawyers link facts together like a chain. And this is what you're going to be doing in geometry. And each of these links is like an if-then relationship. If something is true, then something else must be true. So let's look at a little example. And it's just a made-up example, like the suspect is innocent. That's what the lawyer's trying to prove. Well, how do you know he's innocent? Well, he wasn't at the scene of the crime. Well, how do you know that? Well, the suspect was somewhere else. Well, how do you know that? Well, a neighbor saw the suspect at the same time as the crime is somewhere else. So, well, how do you know the neighbor's telling the truth? Well, because he needs to be able to be telling the truth. You say, well, we know he's telling the truth because he's a good citizen. So each of these are if-thens. If this is true, then this is true. If this is true, then this is true. So underlying each of these conclusions is a principle that says that you can draw this conclusion. And so each link needs to be based on an agreed-to principle, and this is very important for geometry, by the way. And so the agreed-to principle is that if you're not at the scene, you can't be guilty of a crime because you weren't there. That's a principle, a general rule, and the general rule is a person can't be in two places at once. And general rule is if an eyewitness can establish the location of a person, and that the eyewitness needs to be telling the truth to actually accept that as a fact, and that a good citizen tells the truth. So all these are the assumptions that you make, the underlying principles that allow you to draw these conclusions. And you do the very same thing in geometry. When you create a proof, and we're not trying to say if a suspect is innocent, we're just trying to prove geometric statements. And these geometric statements, by the way, are called an hypothesis. That means you don't know whether it's true or not, and you're going to try and prove it. And so to be able to prove a hypothesis, you need to link together geometric statements like a chain, just like above, and we're going to do this exact same kind of thing. And for each link, you need to give the principle, the geometric principle that justifies why you can make this link. And we're going to learn how to do this in the video. And so learning to help do this will help you both in geometry and in your thinking for your daily life. So here we go. In geometry, there's generally two types of proof problems you'll need to do. You'll actually prove an actual theorem. And so a theorem is a geometric statement that you can prove. And here's one. The sides of the interior angles of a triangle add up to 180 degrees. Now, you've known that for many years, I'm sure, but that you can actually prove that is true. Another proof, and you'll get a lot of these kind of problems, is you prove something about a specific diagram. You'll see a lot of these kind of problems. And so the problem will generally give you some kind of a figure, and it'll tell you what you know about this figure. Like these two lines are perpendicular, this line bisects this angle, that sort of thing. And then it asks you to prove something else about it, and you have to say, and you need to prove this hypothesis that these two parts of the line on the base here are congruent. And so these are the types of problems you're going to do. And for both types of problems, this is what you do in general. You start with the hypothesis, right? What you need to prove and what you're given, and you try to link them together with a chain of facts, one fact after another. And for each link in the chain, you derive a new fact from the previous facts you already know. So you're deriving new facts. But you have to be able to use a geometric principle to be able to say that you can actually derive this fact from this fact. And so eventually you get to your hypothesis. So that's it. That's what you do to be able to do a proof. And so and we'll see examples of this. And there are 4 types of principles in geometry that you use. There's definitions, which are the meaning of special words. And we'll see some examples. And the properties, which are basic facts about line segments or angles. There are postulates, which are statements that we know are true, but we can't prove them. They're just self-evident. And then there's theorems. There are statements, geometric statements that you can prove. So here's some examples. But all these examples show that you're deriving new facts from previously known facts. So here's an example of a definition of an angle bisector. An angle bisector divides an angle into 2 congruent parts. So if you see the word angle bisector, then you know that the angle is divided into 2 congruent parts. You're deriving a fact from another fact. Here's a property, this type, and it's one that's kind of obvious, but you will use it. A line segment is congruent to itself. And that means if you have a line segment, it can be used in multiple ways, is basically what that's saying. In different, it's always congruent to itself. And then here's an example of a postulate that says if the corresponding sides of 2 triangles are congruent, then the triangles themselves are congruent. And so if you know that the corresponding sides are congruent, that's one fact, then you know that the triangles are congruent. So you're deriving one fact, if one fact, then the other fact. And then here's an example of a theorem. If 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. And we're actually going to prove this theorem in this video. So in all of these, you know a fact and you're deriving new facts, and hopefully you can build a chain of facts and actually prove the hypothesis. So that's how it works. So when you're done with this, you actually hand something into your teacher, and this is how you write a formal proof. So you have a figure, always usually a figure that you draw, and then you have to write down the hypothesis, you have to write down the facts you were given, and then you build this table where you have the statements and the principles, the reasons why you can make each statement. And usually you start with what's given, and then you determine another fact from what's given, and you have to state the geometric principle you use to determine it. And then you state another fact, and you use the geometric principle you use to determine it. And then the last fact's always the hypothesis, and of course you need the geometric principle for that last step. So that's what a formal proof looks like. So now we're going to do an example. So here's the example to prove that the isosceles triangle theorem, that if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So what you want to do in the beginning is, first of all, draw it and say, well, here are the 2 sides that we know are congruent, and we're trying to prove these 2 angles are congruent. And then you want to brainstorm an approach about how you want to do this, and we look at it and you say, how could I prove this? And so you want to think outside the box. You often need to add lines, they're called auxiliary lines, to a figure, and then it can help you do the proof. So if we imagine that there's a line down the middle, a line segment down the middle from the apex down to the midpoint of the base of this triangle, then we can maybe prove that the 2 halves of the triangle are congruent to each other, and then if they're congruent, then the corresponding angles are congruent. So that would be the approach, and indeed that's how we would do it, right? So we start with what's given, and then we draw a line from the apex to the midpoint of the base, and this midpoint divides the base into 2 congruent parts. And you have to state what principle you use to be able to draw that conclusion, and that principle is the definition of the midpoint. And then we also know that the line we drew is equal to itself. it could be used in both these triangles. And so using the reflexive property, you know the line segment is congruent to itself, and there's the statement of the reflexive property. Now, if you look at this, you see we know the corresponding pairs of sides are all congruent. These two sides are congruent, these two sides are congruent, and the line itself is congruent to itself. So we can use the side postulate to say that these two halves of the triangle are congruent. And there's the side postulate. And then the last one is that there's a famous principle called corresponding parts of congruent triangles are congruent, CPOC-TAC. And this means that when you know that the two triangles, these two halves of the triangle are congruent, then you know that the corresponding angles are congruent. And we've done it. So we've worked it out informally, and then you write a formal proof. So we want to prove that. You draw a figure, you say what's given, you say what you want to prove, and you write it with these, referring to the angle, right? And then you write a statement, and you say what's given, and then you draw a line, and you can just say, I'm drawing an auxiliary line. We know the definition of the endpoint, of the midpoint, that the two halves of this of the base are congruent, and then you know that this line we drew is congruent to itself, and then from the side postulate we know these two halves of the triangle, each half of the triangle is congruent to the other, and then from the CPOC-TAC we know these two angles, the corresponding angles, are congruent. And so we've written it formally now. So that's that. So we've done it. Now we have a couple more slides here, several more slides, and the first is the tips for doing a proof. First, you want to do the proof informally first, then you do a formal proof. And you definitely want to, you're solving a puzzle, so you want to draw the figure on a scrap piece of paper and then brainstorm how you would add facts to this figure, new lines, new facts to this figure based on the principles, and how you would link the facts together to prove the hypothesis. It's like solving a puzzle. And you may need to think outside the box. You may need to add auxiliary lines to the figure. And you can do that, but they have to follow the principles. They have to be legal, as it were. And then sometimes it's helpful to start from the hypothesis and work backwards and kind of brainstorm that way. And then you often work forwards and backwards and meet in the middle, and you say, okay, I've solved the puzzle. And then if you're stuck and you want to look through the list of all the definitions, properties, postulates, and theorems to get ideas, and you want to see the next slide, because I'm going to list on the next slide all the definitions, properties, postulates, and theorems you're going to need for your this proofs unit in your high school class. And it's good to learn these by heart, and then when you get them, you get the problems from your teacher, assignments from your teacher, it's just going to go easy for you. So then once you work it out informally, then you have to write it carefully, formally, like we showed. Okay, so here is an informal description of all the geometric principles you're going to need to know. First is this reflexive property where a line or an angle is congruent to itself. Then we have these definitions of like a midpoint, a perpendicular bisector, an angle bisector, and what you can conclude from that. Like from a midpoint, you know that the two sides, two halves of the line segment are congruent to each other. Then we have the angle addition postulate, where you know that you can add two angles together, and you add the sides of this angle plus the sides of that angle, and you'll get consistently get the sides of the two angles together. So you can add angles together, and you could subtract a smaller angle from a bigger angle, and you get the remainder, the remaining angle. So you can do that, and you'll often do those in proofs. Then we have the supplementary angle theorem, and supplementary angles they add up to 180 degrees. And so if you know that two angles are congruent, like shown here in red, you know the supplements of those angles are also congruent. Then we have the vertical angle theorem, and vertical, that word refers to the vertex, right? When you have two lines that intersect, then the angles on each side of the vertex, like shown here, the opposite side of the vertex, are congruent to each other, and it works both for what's shown in red here and what's shown in blue. The next set of postulates and theorems all have to do with parallel lines, and really what you want to know about parallel lines is shown on this figure, and so you know it intuitively that if you have two lines that are parallel and you draw any line through that crosses both of them, and this line is called a transversal, then all the angles shown in red and all the angles shown in blue here are congruent. All the reds are congruent to each other, all the blues are congruent to each other. And these are all captured in a set of postulates and theorems that you'll learn. But it really, if you remember this picture, this is what you need to know, what's shown in the picture. But just to go through them, the corresponding angles postulate says that the angle that is the same place on the first parallel line and on the second parallel line, like this lower left-hand red, is congruent to that lower left-hand red. And that's true for all four of those angles. Alternate interior angle theorem says that the angles that are interior, like inside the parallel lines, on the opposite sides, the alternate sides of the transversal, are congruent to each other. That red's congruent to that red. You'll use this a lot. And you could see how you would prove that. These are two corresponding angles, right? So they're congruent. And plus the vertical angles are congruent. So therefore the alternative interior angles are congruent. And so you can, the same with the exterior angles, alternate exterior angles. The same side angles are supplementary to each other, both the interior same side angles and the exterior same side angles. So if you have two parallel lines, you know all that. Now, the principle works both ways, and that if you know an angle from the top line that's shown here and is congruent or supplementary as shown with any angle on the bottom line, then you can prove that the lines are parallel. So it goes the other way. You know something about the top, you know something about the bottom, and it fits this pattern, then you know the lines are parallel. Okay, so the next set of principles are all about triangles. And so we have the triangle theorem that says that the angles add up to 180 degrees. But another way to put it is if you know two pairs of corresponding angles are congruent in the two triangles, then you know the third pair of corresponding angles are congruent because they all add up to 180 degrees, right? So that's very helpful. Then we have our side-side-side postulate. If you know that the corresponding sides are congruent, then you know the triangles are congruent. We have the side angle side postulate that says if you have a side and another side are congruent, corresponding sides are congruent, then and the included angle is congruent, then the triangles are congruent. Now it has to be the included angle. If it's a side are congruent, a side's congruent, and the angle that's not included between the two sides, you can't prove that the triangles are congruent, because you can see in our example that's true in these two triangles. Those corresponding parts are congruent, but they're not the same triangle. So it doesn't work. SSA does not work. However, it does work if you have a side, and an angle, and that angle is 90 degrees. It's a right triangle, the two right triangles. It's called the hypotenuse leg theorem. If the hypotenuse and a leg and of a right triangle are congruent, then the triangles are congruent. Okay, then we have the angle side angle. If those corresponding parts are congruent, then the triangles are congruent. And because of the triangle theorem, you can really say that if you know any two angles and any one side are congruent, then the triangles are congruent, because you always know the third side. If you know two angles are congruent, two sets of angles are congruent, you always know the third angle is congruent as well. So then finally, so these are all about proving triangles are congruent. And once you know they're congruent, then you know all the corresponding parts are congruent. Now two more on triangles, we have the isosceles triangle theorem, which we already proved, and then we have this perpendicular bisector theorem that says that if you have a perpendicular bisector and you pick any point on the perpendicular bisector, it is equidistant from the endpoints of that original line segment. And so these two lines are the same, are congruent. And you can see how you would prove that. That's why I put it here, is you can see that these two angles are congruent, these two sides are congruent of these, and these two angles are congruent, and this side is equal to itself. Therefore, you can prove it with the side angle side postulate that these two triangles are congruent, and therefore that distance is the same, is congruent. So that's it for triangles. These are everything you need to know about triangles, and then you'll be able to do the proofs in your for your class. Finally, we're going to do quadrilaterals, and there's things you want to know about quadrilaterals. First, that there's parallelogram, and the definition of a parallelogram is that you have that the opposite sides are parallel. If you know that, then you know the opposite sides are congruent, the opposite angles are congruent, and the diagonals bisect each other. And so if you know any of these, any one of these, you'll know the other three. So if you know that, then you know the rest. And so you know one fact, you'll know these other facts. Now for a rectangle, the definition is that the four angles are all right angles. We also know that the diagonals are congruent to each other. So if you know that, then you know it's a rectangle. Rectangles are also parallelograms, so if you know it's a rectangle, you know all these other facts as well. And then we have a rhombus, which is a parallelogram where the sides are equal length. That the diagonals of a rhombus are perpendicular, and plus a rhombus is a parallelogram, so you know all that is true about a rhombus. And then a square is both a rectangle and a rhombus. So all this is true about a square. So this is it. These are pretty much everything you need to know to be able to do the proofs in your geometry class. So to summarize, you do a proof like what lawyers do in the courtroom. You have to convince the jury that what you're saying is really true. And you do proofs. Doing proofs will help you think logically, both for math and for your daily life. And it's like doing a puzzle. And to do it, you start with a figure, the hypothesis, what you need to prove, and what you're given, and you try to link together a chain of facts from what's given to the hypothesis. And for each link in the chain, you need to derive, what you're doing is deriving a new fact from previously known facts. And you're doing this based on geometric principle. It has to be based on a principle. And if you succeed, you will eventually get to the hypothesis, and that's it. You've done a proof. So you always want to do proofs informally first, think it through, and then you write it out formally. And it is very helpful if you want to be able to do these proofs. You learn all these principles by heart that were shown on the previous slide, and it will make doing proofs much easier. So that's it. I hope that this was helpful. Thanks. And to end the video, we'll go back to this summary page.